So I'm going to have a two-tier application, okay, which is going to have a PHP application which will be displaying some data from a database. Okay, so this PHP application will be in a horizontal scaled fashion. So there will be three containers or three pods will be running for the PHP application, and it will be exposed to the external world via load balancer. Okay, and I'm going to have a MySQL database from where my PHP application will be displaying the data. And to retain the data inside the MySQL, I'm going to attach a persistent volume. So we have talked about this persistent volume and other steps, right? We'll see how to attach a persistent volume so that my database will retain the data. And then we are going to talk about secrets. Secrets are the concept where when you want to store some informations, sensitive information in a safe manner, then you can use the secret. So we'll use the secret to store the MySQL username and password, because all these things will be used by my application to connect to the DB. So we'll store the MySQL username and password as a secret, and that will be used by my PHP application to connect to the MySQL DB. Okay. And next thing is we are going to create a empty database. So I want to load some data into the database. From there, I want the data to be displayed. So we will create a job. Yesterday, we have seen a cron job, which is scheduled to run a job. Jobs are like one-time running activity. This will be a typical use case. Like you have a database and you want to load some data into the database, we can use it. Okay. So this is in this architecture, we are going to cover how to attach a volume to a container, and how to store secret information, that is sensitive information as a secret, and how to execute a job. Okay. And next, we will be storing this encrypted username and password as an environment variable. We are going to talk about that. And also the MySQL database, I'm going to expose this as a internal service, because whenever I'm using a database, I should not be make it available external to the application. So I am going to bring the MySQL database as an internal service, and then my application will be exposed as an external service. So this is the architecture. We are going to work on it now. So let's start writing the YAML files. Let me go into the two. So in this diagram, the first thing I'm going to do is I'm going to create a secret. Okay. So let's see, how do I create a secret? Add secret.yml. Let's do this. The API version for secret is v1. API version v1, and kind is secret. And for my MySQL image, I always need to pass a for my MySQL image, I need to pass three mandatory parameters. That is MySQL root password. When you install MySQL server, there will be a root user available. So I need to set up a root password, password for the root user. And then I need to create a table. And for the table, I'll be creating I'll be creating a database. And for the database, I'll be creating a username and password. Okay. So this is what we are going to set this as a secret. In the secret, I'll be storing my MySQL root password, MySQL user, and MySQL password as a encrypted format. Okay. So we will store these three values as in my secret. So let's do that. So the kind is secret, and next is meta data Name of the secret, let me keep it as MySQL hyphen MySQL credentials and labels. Let me use a label called observe training. And this concept I'm going to use are like, I'm going to use a LAMP stack here. So because I use Linux, Apache, MySQL and PHP, my application is a LAMP stack. So let me use the name LAMP. And next is the type of the secret. Okay, so the type of the secret, I'm going to use it opaque. In opaque format, you can store the base 64 encoded value of a sensitive information. Okay, so that Kubernetes can automatically decrypt the base 64 encoded, and people who are having access to the secret will be able to see that, but in the source code, it will not be visible. So I'm going to use the type as opaque data. So I told you I'm going to create three things. One is my root password, and another one is user, and another one is the password. So let's do that. Root password, user, and password. I already have the base 64 encoded value for the passwords. So I'll just copy paste the base 64 encoded values. MySQL credentials, and the type is opaque. I mean, I'm using the base 64 encoded value. Let's save it. And apply this QCTL apply from F secret.yaml. The credential is created. Let me check it in the dashboard. So if you go to your dashboard, if you see the secrets, you can see a MySQL credential is created, and it is having three values: password, root password, and user. So if you see that, this is my actual value. So Kubernetes can decode the base 64 and it can use. As I have access to the secret, I'm able to see that. Okay. So the next thing we are going to do is we are going to create the database in the diagram. Okay. So for the database, first I need to create a persistent volume claim. This will create a persistent volume which will be using my storage class. Okay. First, let us create a PVC that will be creating a PV using the storage class. And next, we will create a deployment for your MySQL. So let's start doing that. First, let me create a PVC persistent volume claim. So the API version for PVC is also V1. Okay. Volume claim and metadata, and let me name the PVC as database labels. Training maps Next is in the annotations, I'm going to provide the default storage class, because if you go to your dashboard, if you check the storage class, you can find a storage class called GB2, and this is the default storage class for the cluster. Okay, so when I create a PVC, this is the default storage class that will be used. That is what I'm mentioning in the annotation. So volume dot alpha dot Kubernetes dot io slash CLA plus default and for the, so I need to give the specifications. Okay, here where I'm going to tell what should be the storage type. That means whether the disk should be added as a shareable disk or a write only disk. That means a read and write only disk. So whenever you create a storage for database, it should be a read write once mode, because you cannot share the data which is added to a database. You cannot share it with other process. It will create confusion in the permissions. So the first thing I'm going to define is the access mode. Access modes. This read, write once, and resources. If I want to provide any restriction, like for example, what should be the maximum CPU, or what should be the maximum memory that container can use, or like that, you will always define it like resources request. Here I'm going to tell what is the size I needed for the disk. So resources requests, and I'm going to tell storage is 1 GB. So I want a volume of 1 GB to be attached to this container. Okay. The next thing is 3. And so my PVC will be ready after this code. Now let me create a deployment. So API version apps / v1 and kind is deployment and metadata and SQL labels training stack. And next I'm going to provide the specs for the deployment. Spec. So normally DB will be a single database. Okay, so replicas 1 and so history limit. So this is how you can define your custom history for your deployment, because when we saw yesterday, Kubernetes is going to keep that value by default as 10. So if you want to specify your own history limit, that how many deployment history it can keep, so this is how you can define it. So you can, it is saying 5 histories. Okay, instead of 10 I'm changing it to 5. This is how you can do it. Okay, and next is selector. labels. So let me create a unique label called app MySQL. This I will use it on my template selection and also in the service selection. I will use this label. So next, let me define the template. Data, labels, MySQL. Specs for the template is liveliness and image. So I'm going to use MySQL 5.7. SQL 5.7. Let me call as MySQL. I want to restrict the CPU and memory for this machine. So it will be resources STS request. So I can say what is the maximum CPU it can use. CPU should use 1. So one CPU it should use only one CPU max, and memory we can say 2 GB. So this is the maximum resource this container can use. One CPU and then 2 GB of memory. And then I'm going to pass the environment variables, because when we see the container, that is MySQL image, it is looking for 4 default variables. Those are your MySQL root password, database, username, and password. Okay, so let's first pass the MySQL root password, but here I'm going to use it from the secret. Okay, so let's see how do I do that. Hyphen name MySQL underscore root underscore password, and I'm going to use value from secret key reference, and name of the secret is MySQL hyphen CREDN, and next is the key. I think I have stored it as root PW. Yes, so this is the key root PW. So this is the first environment variable. Next, let me create the user, pass the user environment variable. So name is MySQL underscore user, value from, sorry, from secret key reference MySQL hyphen credentials, and the key for this is user. Same way, let me pass the next environment variable, MySQL password hyphen SQL underscore password, and the same option, value from secret key reference is SQL hyphen shells, and the key is password. And the next environment variable I should be passing is my database name. Okay, so I'm using an online movie database. Okay, so they have a script to load that. So let me create that. So with the same name, MySQL underscore database. And so if I want to directly pass a value, it will be like name and value. So here I'm not using it from the secret. I'm directly passing a value. Value is okay. Okay. So I'm just passing the value because my application will be looking for this database inside that. Okay. So this is how you can pass environment variables. If it is a direct value, you can give it like name and value. If it is from secret key, you can use this option, value from. Okay. And next thing is, whenever you do a deployment, it is always a best practice to use a liveliness probe. That means in the best practices of microservice, I have told, always use liveliness probe and readiness probe, right? So liveliness probe is something you can tell Kubernetes how Kubernetes can check whether this container is healthy or not. Okay, so that means this is a database container. If the container is responding to me on the database port, then you can consider this container as a healthy. Okay, this is called liveliness probe. And readiness probe, we will see an example when we are doing the stateful set. So this is where when I can consider this application is ready. Like for example, imagine you are bringing up application. It is going to take at least 2 to 3 minutes to bring up the complete application. You cannot straight away add it to the load balancer, right? Only when the application is ready, then only you need to attach it to the load balancer. So that is where this readiness probe will come into picture. We'll see that in detail when we go into the stateful set concept. Okay. So as of now, here we will use the liveness probe. We'll see how to use the liveness probe. So the option is liveness. ROB, liveness probe. So I wanted to make a TCP connection to, so TCP, so CKEP, TCP socket, and port is 3306. Port is 3306, and next part is we're going to define the port for the container. So the default port in which MySQL is running is 3306. Port is PORTS ports hyphen CONTAINER container port is 3306. And next is I'm going to give my volume mounts. So I want to mount a volume. There I need to define where exactly the volume has to be mounted inside the container. If you remember our Docker training in the Jenkins, we have attached the volume to the var Jenkins home directory, right? Like that, for MySQL will be storing the data into the directory var lib MySQL, and inside that there will be a directory called data. So I want the volume to be attached to var lib MySQL, and inside that I should have the data folder. I should have the volume mounted to the data folder. So let's do that. So the option is volume mounts, and I need to define the mount path. Define mount path. So let me call it as var lib MySQL sub path. I want it to be mounted to the data directory, and let me provide a name for the mount path, and let me call it as name database. Okay, so this is my container information is completed. So the image is this, and I want to use allocate a one CPU and 2 GB, passing 3 environment variables, 3 coming from the secret, and 1 is a direct value, and I'm configuring a liveliness probe, and the port is this, and this is my volume mount point. Okay, so the next thing I'm going to do is, so volumes, I think this should be fine. Should be in line with the container. Yes, they are. Volumes hyphen name database. So this name refers to the volume mount point name. Okay. So this is the name mapping I'm doing. Net database and R SISTET volume client name is data. So this client name refers to the PVC client I'm creating. This is the name. Okay. So this is where I'm mapping my PVC with this mount path. Okay. So my deployment is ready. Now let me expose this as an internal service, because database you will never expose it to the external world. So I'm going to expose this as an internal service. Let's do that. So API version v1 and kind is service, and metadata and MySQL labels. So training specs for the service are PHPMySQL ports, and I wanted to listen on the port number 3306, and protocol should be TCP. And selector is colon MySQL. So this is the selector. So basically, it is going to refer to my template. So this is selector. This is where it will refer to the replica set. And then I need to define the type. So till now, we were using type as load balancer. So for exposing a service as an internal service, the type is cluster IP. CLUSTR cluster IP. Cluster IP on caps. Okay. So I have created a PVC and I have created a deployment and I have exposing this as a internal service. Okay. So let me save this and apply this and I will show you what are all the components it's going to create. So kubectl live-f db.yaml. Okay. So it's all created. So let me go to the dashboard first. There I will show you. So it would have created a, okay, the deployment is still coming up. I think persistent volume is claim is creating. So it should create a replica set and it should be creating a pod. And there will be a service. The service is up, but at the same time, it would have created a PVC and persistent volume should have been done. There is a PV and PVC. Let me see the deployment. Yeah, now it is done. And it would have created a pod. This pod is created. So I have a PV created and from there the PVC is made available. Okay. So let me show what it is doing in the Amazon. Okay. Prior to that, let me check the pod on which machine it is running. So the pod is running on the node with the IP 10.0.23.10.0.23.99. Okay. So let me show you the Amazon screen. So this is my Amazon screen. Let me just filter the running instances. So there are 4 running instances. So this is my one node. No, this is not the node where my pod is running. So if you see the storage of the pod, it has only one volume attached. But if you see the other pod, sorry, other node, where there is a 1 GB storage got attached. And if you check the volumes, in Amazon, there is a separate section for volumes. If you check the volumes, there will be one volume has been created. Okay, this is where it is. The other volume is it was created during the previous lab. Okay, so this is the volume that Kubernetes has created and it is attached to this particular instance. And it is attached to the instance where the MySQL pod is running.